Hi, this week we're going to start with this investigation in which we're going to be looking at a couple of solar system objects using the Stellarium animation and then coming up with some ideas for observations, measurements, and we might do some calculations and we're going to test some hypotheses that you're going to come up with. This is essentially a process of scientific thought and practice that we need to practice as part of this course because we do have some learning objectives that are associated with this kind of exercise. So if you're interested in knowing more details about why we're doing this, there is a page here that contains the learning objectives of this particular activity. Now, we're going to go through some step-by-step setup of the observation process, and I'll show you how to do all of this using a Stellarium. And I'm going to put that video here at the end, which is this video. It's kind of weird. So I'm recording the video that is going to appear here on the Canvas page momentarily. In any case, we are going to be repeating some of these steps later in this investigation, so make sure that you follow them very, very carefully. But we can also do it together, so let's go ahead and try that in Stellarium. So this is the software Stellarium which you have seen before in Lab 0. This time we're going to use it to do some actual observations. So the first step is going to be to press F6 and make sure that our location is Tacoma. So we're going to type in there Tacoma to search for the location, and we click on it, and then we are magically transported to Tacoma, United States. Close that. And then step number 2 is going to be to press K to pause the animation. So you might notice that the time at the bottom portion of this animation is increasing. So this is actually animating the sky in real time. But if you press K, you can make that time stop. So you're seeing a snapshot of the sky. That's a very important step, as we'll see in a moment. Then we're going to press F5 to change the date and time to 2019 January 1st at 000 at midnight. Happy New Year. Now, once we're there, notice that how the sky is changing based on the time and the location and all that. So next thing is going to be, we're going to look for our object of interest. Press F3 to open up the search window. Look for example, Venus, if that's your group. Some of you will be looking for Mars instead, but we'll look for Venus if you're in the Venus/Jupiter group. And then the animation takes you to wherever planet Venus is. You might notice that we're seeing nothing at this point. The reason is that this animation also shows you the ground, and we can remove the ground by pressing the letter G. So press G, ground is gone. Another thing that will happen as we do this experiment is that we're going to have to change the time, and eventually the sun's going to come up and it's going to be too bright, and then the stars disappear, including the planets, which are not stars but are dots in the sky. So anyway, if you press A, that's going to allow us to remove sunlight. So the sun's not going to interfere with our observations. We can do this 24/7. Our next step is going to be to press Ctrl M. I'm going to do it by clicking on one of these buttons instead, but it's the same thing, Control M. And what that allows you to do is essentially remove Earth's rotation from our observations. If we don't do that, as we do our observations later, things are going to rotate with the Earth, but we can remove that by mounting our telescope in something called equatorial mode. So if that's not clear yet, that's okay. We can talk about it later. For now, just press Ctrl M to remove Earth's rotation from our observations. A couple more things we have to do to make it a little more realistic. Press Alt P, that gets rid of the planet labels, and then Alt S gets rid of the star labels, because we don't see those in the real sky. Then I'm going to finally zoom in to our object of interest, Venus, and I'm using the wheel on the mouse to do this. and we're gonna zoom in all the way to a field of view of 0.2 degrees. What that means is there's a number here at the bottom of the screen that shows you the field of view. Right now is 0.208 degrees in my animation, and what we want is to get as close as possible to 0.2. If you don't have a mouse but you have the keyboard instead, you can use the page up, page down keys to do the same thing, zoom in, zoom out. If the zoom is too much or too little, because again we're trying to get as close to 0.2 as possible, you can press Shift, page up or page down, and do some fine adjustments. So let's try to get as close as possible to 0.2, and let's say 0.201 degrees. That's very, very close to 0.2. You might not be able to get exactly to 0.2, but as close as you can, that's good. The idea here is that we're all doing the same kind of observation with the same field of view, with the same zoom setting. Okay, in our next few steps, what we're going to do is we're going to conduct some observations of this planet. Again, notice that the date and time, they're fixed. It's not changing. If you see this moving, increasing time, press K again to pause the animation and then go back to 2019-11000. We're all going to do the exact same observations with the exact same field of view. First, we're going to see what happens to this planet over a time period of 48 hours. And how you do that is by clicking on the hour control in the daytime box. So we're going to click here. That increases the time by 1 hour. And click again, increases the time by 2 hours, and so on and so forth. So 2 a.m., 3 a.m., 4 a.m., and so on this day. Essentially, you can imagine this as going out on this night and every hour taking a picture of planet Venus to see how it changes, to see how this portion of the sky changes as the night progresses. So we're going to do this for 48 hours, which is 2 days. So I'm going to go a little bit quicker so you can see if there are any changes or not, or if something is happening. I want you to write down any sort of observation or anything interesting that you found during that 48-hour period. If you didn't find anything interesting, that's an observation as well. Nothing happened, that's an observation as well. Alright, so that's the 48-hour period. Then I'm asking you to also look at what happens over a period of 30 days. So the day controller is over here, date time. So it's the third controller in the date and time box, and so it is January 2nd here. We want to see what happens over a month, so we're going to just keep increasing this controller until we hit January 31st. And again, if you see anything interesting happening there, write it down. January 31st, that was a month of observations. And again, the idea is that essentially we're replicating the observations that you would do. You take your telescope out every night and you point at Venus and you see what's happening night after night after night. So that was 30 days. And then the final thing that I'm asking you for Venus is that you see what happens over a period of 24 months, which is 2 years. So we're starting at 2019 January, we have to go all the way to 2021, the year 2021, right? So let's go ahead and change this date. So right now is January 31st. Now we're going to go to February 31st, actually jump to March. And then April, May, June, and so on and so forth, right? So you change month by month and see if you notice anything interesting there or not with planet Venus. Okay, we're going to go all the way to 2021, the month of January. There. So I just showed you the observations for Venus over 2 years. In each of these steps, the hourly, daily, and monthly observations, I ask you to write down some observations. Did you notice something interesting? Did nothing interesting happen? Again, that's also an interesting observation. Important observation. keep in mind that the purpose of this exercise is to replicate the process of science, which always begins with an observation. So there's no observation that is wrong here. Anything that you can point out that you find interesting, relevant to share, go ahead and say it. Together, we're going to come up with perhaps the observations that are more relevant for everybody, and then we're going to start doing something with those observations, or designing an experiment around those observations. When you're done with your observations of the first planet, Venus for some of you, Mars for others, then we're going to look at the other planet. But before we do that, let's make sure that we go back to 2019 1/1, January 1st at midnight. One more time. After you've done that, press F3 and go to your other object. Those of you who did Venus will go to Jupiter. Those of you who did Mars will go to Saturn instead. So I'll show you Saturn. And Saturn is always fun to look at. Again, make sure that your field of view is still 0.2. You might be tempted to zoom in again because Saturn is always fun to see, but don't. Again, pretend, right? We're all using the same telescope, so don't change that. And now you're going to do the same thing with Saturn. You're going to do hourly observations, and I'm not going to show you the entire 48 hours and whatnot, but this is what you'll do for 48 hours, and then daily observations for a month, and then monthly observations for 2 years. And you will notice things in this simulated observation set. Write down as much as you can from the hourly, daily, and monthly observations. When you're done doing your observations, you're going to write some summary of those notes that you made. So let me show you the Canvas instructions again to talk about that part. Okay, so here we are back in Canvas, and there are some instructions here about what to do now. After you've done these observations for your 2 planets, either Venus and Jupiter or Mars and Saturn, go ahead and first write your most notable observations. Pick 5 that are your favorite and make sure that at least one of those is about either Mars or Saturn. So don't just write observations for one planet. Make sure that you write for both. You might have more, but concentrate on the 5 that you think are most interesting. Then think about measuring things. What are things that you could measure with only these observations and nothing else? Remember, this is all we have. Just all we have is stellarium and those pictures of the sky that we could take with our simulated telescope. What can you do with that? And I'm saying here that I'll give you a hint in the video instructions. So let's do that here, or the video version of these instructions. So my hint is this. There is a tool that you might not have available right now, but I'll show you how to activate it later. It's a tool called Angle Measure. When you activate this tool, you can click and drag on the screen and measure angles, or think of it as distances in the sky. So how far apart these 2 points are in the sky. It's given in an angle, and we can talk about those details later. So this is 2 minutes 51 seconds of angle. Something smaller might be 1 minute and 4 seconds, and so on and so forth. So there is a tool that we can use to measure maybe sizes of things or distances between different things in the sky. And we also have the time control, so we can perform observations at any time. So perhaps think about some time series of data. So some measurements of distances or sizes over a certain period of time. Finally, you're going to be working in groups for this. So there's going to be the group observing Mars and Saturn, and then the group observing Venus and Jupiter. You're going to be sharing your observations in a discussion, and then maybe you see some observation that other student made and you find that interesting, so make a comment about that observation and just explain why you think that that's an important observation. Make sure that you pick an observation that you did not make, not one that you already made and are agreeing with it with some other students. So just find one new observation different from yours. It's going to take me a few days after the due date for this assignment to review all of your observations, your suggestions for measurements and whatnot. I'm going to collect all those together, come up with the next step of this investigation. Once again, if this feels a little bit out there, like it's going nowhere, like you don't know exactly what you're doing or why, I would like to point out one more time, we have this guided investigation learning objectives that explain why we're doing this and why we're doing it in the way that we're doing it. As I mentioned at the beginning of this assignment in the introduction section, this activity is mostly going to be graded on active participation. Try to avoid looking for correct answers or high-level conclusions from what you're observing. Just concentrate on the data. What are you looking at? What kind of observations are you making? What kind of experiments do you think we should design and why? In a way, all answers are correct here, as long as you're following these instructions and also making sure that whenever you submit your assignment or your responses to this discussion, you are making sure that you are fulfilling this conditions set by the rubric. Make sure that you have a list of 5 observations. At least one of them should be about either one of the 2 planets. 3 things to measure, and make sure that you explain why you think it's important to measure that thing, and then respond to another student. There's points associated for each of this. As long as you do that, you get the full credit for this assignment. Well, I hope you enjoy this activity. We're going to come back to this later. We're going to do this at least 4 times in the quarter, 1 every couple of weeks. Talk to you later.